The question that I have is, could you describe the unconfined compression test? The unconfined compression test can be considered as a special case of the triaxial test. Just to refresh our memory, here's a part of a slide that I used in the video on triaxial test. Remember, we use a special cell called the triaxial cell in order to perform a triaxial test. There are two things that we do here in a triaxial test are not done in an unconfined compression test. Number one, in a triaxial test, we apply a confining pressure, right? This allows us to control not only the vertical stress but also the horizontal stress. In other words, the specimen is confined before applying the vertical stress. In the unconfined compression test, we don't do this. Hence the name, the unconfined compression test. Number two, in a triaxial test, the specimen is fully saturated. We measure the volume change in some tests. We measure the pore water pressure in some tests. We don't do any of these in an unconfined compression test. Now let's talk about the unconfined compression test. Just to summarize what we talked about in the earlier slide, the specimen is not confined and therefore the total horizontal stress is zero. If the specimen is not already fully saturated, there's no facility to saturate the specimen here. We don't measure the pore pressure change or the volume change. So the test is basically done like you would normally test a specimen of steel or aluminum or something like that. You just increase the vertical load and keep measuring the vertical displacement gradually until failure. From the knowledge of the cross-sectional area of the specimen, you can calculate the vertical stress. Vertical stress equal P over A. And similarly, from the knowledge of the initial height of the specimen, you can calculate the vertical strain. Vertical strain would be simply delta divided by L. You just keep plotting sigma versus epsilon until failure. The failure value of the vertical stress is what is called the unconfined compression strength. Some soils may exhibit strain softening and you will be able to capture that as well. By the way, to capture strain softening type of behavior, you have to conduct the test under a displacement control mode. In other words, you had to increase the displacement little by little by little so that you can go over the peak and continue the test until the ultimate point. If you do that under a load control mode, then you'll keep increasing the load, right? But as soon as you come to the peak, you won't be able to increase that anymore. The specimen is going to fail right there. You will not be able to capture this falling part. So that's all there is to it. So it's basically a crude form of the triaxial test.